In this video, I'm going to look at some bargain basement soldering irons and see if there's any real deals out there. So I've been searching through AliExpress. I keep seeing these super cheap soldering irons, like a few dollars, and are they really any good? So I've actually set up 3 simple tests, going from a beginner application of just joining 2 wires together, right through to something like soldering a surface mount PCB that you've made yourself. I've picked up 4 soldering irons with my own money, starting from the cheapest I could find, which is basically this one. It's absolutely disgusting. Just wait till you see what happens with it. Some other super cheap ones that seem okay, right through to relatively expensive. So I'll test them all and I'll give you my opinion on whether I think they're any good and whether I think they're suitable for a beginner or a hobbyist to buy. So just to be clear, I bought all the soldering irons with my own money. I'm just going to use the tips they got delivered with, and the tip does make a big difference. They're all using the same type of solder, etc., etc. So it's a fair comparison, but it's my own opinion on whether they're any good or not. And if you keep watching right to the end, I'll show you my bargain microscope setup for soldering these really tiny surface mount components. And you really need something like this to be able to solder those super small components, regardless of the soldering iron you buy. So with that, let's crack on and we'll start with an unboxing of the various soldering irons. So let's have a look at unboxing these. The first one is this monstrosity. So it's labelled soldering iron 220 volts 100 watts. It looks absolutely awful. It basically arrived like this, partially opened. So let's take it out. Whoa. Yeah. So this was the cheapest one I could actually lay my hands on. It looks terrible. I mean, I guess the tip can be changed by taking out these screws, but look at the state of it. And also, all of the soldering irons came with this type of plug, which if you're in the UK is a bit of a problem. You basically need an adapter like this to go to the standard UK 3-pin plug. Luckily, I have one on hand. So this is the first soldering iron we'll be looking at. I have no hope for it. Also purchased was this one. So it says a 60 watt soldering iron, adjustable temperature EU plug, which again is not so useful in the UK, but again this was one of the bargain basement cheapest ones. So here it is out of the pack. I just noticed there's like a little plastic cover over the tip. Just make sure you take that off before you plug it in, else you're going to have a smelly experience. So it said it as temperature control, but by temperature control it basically means this little dial. I'm going to set it on around 400. It feels properly flimsy. It actually feels quite nice in the hand though. The next one on my list was this one. So this is an 80 watt adjustable temperature soldering iron kit. It says LCD, so sophisticated stuff. Again, EU plug. Oh, look at that. Wow. We get instructions, a little bit of a sponge which obviously needs to be wet, and a selection of tips. Look at that. I can't imagine what you'd need this big one for. Okay, look at that. It's not really screwed together at the minute, but it's got a tip in place. We'll leave that one on, tighten it up. As you can see, it actually has some kind of temperature control. Excellent, looks okay. The next one is really this one. So it's a digital setting iron station tips. Rather a big mouthful there. Let's have a look at it. Comes with a manual. Look at that. It comes with, I guess this is some kind of anti-static clip. So the soldering iron actually comes with this sort of 5-pin plug that plugs into the controller unit, and we need to put a tip in. Here's the heating element. Actually comes in the bag separate. And here is the control unit. So you can see it's got a dial for changing the temperature, soldering iron screws in there. Most importantly, for me anyway, it's got this sort of kettle lead plug. So that's really useful if you live in the UK. And you can just plug in a standard UK kettle lead and it'll work. So that looks pretty promising. So I've just plugged this soldering iron in. Look at the smoke. I don't know if you can see that, but the smoke's billowing off it. Oh, it absolutely stinks, man. Oh, look, I don't know if you can see that, but look at the smoke billowing out of it. This is the first time I've plugged it in. Oh, I might immediately have to stop doing tests. Boy, it's horrible. So the first test was going to be the absolute most basic test I can think of, right? So simply you just need to join, say, two wires together, the absolute most basic test. So what I'm going to do is I'm going to tin both ends of this wire and then we'll join them together. Let's see if this soldering iron's hot enough to actually do anything. I'm actually scared of using it. So despite all this smoke, I cannot even get it to take solder yet. No. I'm going to knock it off, guys. It's absolutely garbage. It stinks. It's churning out smoke. Look at the state of it. No. So next up is this soldering iron with the blue handle and the temperature control. One annoying thing with it is that the lead on it's really short. Maybe, I don't know, 2 foot, half a metre, maybe a metre, pretty short. So I've plugged it in and as you can see, a red light inside. Okay, so it's taking soldering out. It's been just over a minute from plugging it in to it's warm enough to at least melt the solder. Look, put quite a lot on the first time. Get the tip covered, and let's just use this to tin the wires. Okay, so first test, let's join these two together. Made a pretty awful job of that, but as you can see, basically no problem whatsoever. I didn't expect there to be a problem with this one. This looks a usable unit. We'll see a much more rigorous test or a much more difficult test later when we go to through oil components and surface mount. For the basics, this one seems fine. The next one is going to be this red handled temperature controlled one, which looks a lot more sophisticated. So I've plugged it in, press the red button, and you can see it actually starts turning on. That's pretty cool, you know, you can set the temperature. I set the other one to 400, so let's set this to 400 as well. It's probably too hot for this solder, but there you go. Okay, and this is actually showing the current temperatures, so it's actually a lot quicker. So this is meant to be an 80 watt soldering iron. It's already reached the temperature as well. Nice. Okay. I mean, absolutely no problem. For basic work, this red handle soldering iron seems absolutely up to the job. I really like the temperature control, it seems that's pretty cool. So I just plugged this one in and it looks pretty cool. The temperature gauge is weird. I wonder if you can actually change the language to English because it's in Chinese, so I don't know what any of that text says. But anyway, it looks pretty cool. Is it hot enough to melt the solder? Yeah, it's hot enough, but it's not very hot. So temperature's now set to 395. And just wet that tip. So let's just do that basic test just to make sure. I think it's going to work, no problem. The tip's probably too fine for joining these two wires together. It's a bit of a struggle, but oh, it's a messy one. To me, that's not a soldering iron problem. It's a tip. The tip's too fine for this particular job, but it works. You can see it's joined them, no problem. So in a previous video, I actually made a controversial comment. I said I always wear safety glasses when soldering because I'm worried about it splattering in my eyes. And this is exactly the situation I was speaking about, particularly when I'm unsoldering. Like, you know, this is, if I pull this now, it's under quite a lot of tension. And as I warm it up, well, this tip's too small for this job. Like that ping there has the potential just to flick solder anywhere. I mean, if there's a non-zero chance of it going in your eye, why wouldn't you wear the glasses? But anyway, it's not about the glasses today, it's about soldering irons. And this one is pretty cool. I think it's good, it's just the tip's too small for this. The smaller the tip, the harder it is to heat up a big piece of metal like that wire tip. So that's why this struggles. But in terms of the soldering iron, it looks pretty neat, so I'm going to switch it off. So after that first test, I think it was pretty obvious that this is absolutely garbage. Don't waste a single penny on that rubbish. Simply don't even entertain the idea of buying it. It's just completely useless. But the other three we tested, these three, they all worked reasonably well. There's absolutely nothing wrong with them. They're all adequate for that really basic job of just soldering wires together. So if you might need a soldering iron once a year, then really just buy the cheapest one to get hold of the blue one. It's perfectly adequate. So let's move on to the next test now. And this is more like if you're a hobbyist and you're soldering up little components on little copper strip boards and things like that. Let's test these soldering irons and see if they're any good for that application. So soldering those wires together is almost like a beginner application where you just need a soldering iron for the absolute basics. You might use it once every couple of years and it'll do a job. They all manage that, I would say. The next one is sort of more hobby level where you want to build your own circuits. So you might want to put capacitors, resistors, ICs into a circuit board like this and build your own circuits up. So we're going to do a little bit of a test like that now. We'll start with the cheapest soldering iron and work up. So I have the blue soldering iron warmed up. I'm going to stick this capacitor in first. Okay, So the way I tend to solder these things, because I don't have all the fancy gear to hold everything in the right place, is I just wedge the components in, make sure it's aligned nicely on the board, then solder the other pin. It's okay, not perfect. It seems to take a lot of solder and holding on, even though it's on basically its maximum temperature over 400. But it's certainly soldered those in. Let's whip those off. Okay, I'm happy with that. For basic through-hole components, it seems okay. How does it fare with the IC? Let's try that here. What are we actually dealing with? So IR2153. So that's actually a self-oscillating half-bridge driver. I use these quite a lot of work and I just dug it out of the cupboard. I've pushed it through the board. Let's just solder up a couple of these pins. We won't do them all. I mean, it works. Is it brilliant? No, it's difficult. It's a struggle, I would say. Look, it's not a very good, acceptable, but not great. So I've got the red soldering iron set back to 400. Let's smash a capacitor in again. It's already up to temperature apparently. I mean, it's fine. Let's have a look at the IC, see if we can get these pins. That feels nicer actually. Happy with that. That seemed acceptable. So this slightly nicer iron with a slightly better tip seems to actually perform a little bit better. So I've plugged the iron in with the external control unit now, set the temperature to 400. Let's see if we can get this capacitor soldered in. It's a bit of a struggle because, again, the tip's very, very fine. I mean, yeah, it's reasonable. Let's do the IC. A bit of a struggle. I mean, part of the problem is because of this thin tip, there's actually quite a lot of copper on this board, right? You know, there's quite a lot of metal to heat up to the temperature required to melt solder. So that means you have to leave this soldering iron on for quite a long time and all those kind of things. But is it good enough? Absolutely, it'll work. Is it worth the additional money over the red handle soldering iron? Probably not. It's just a little bit of a struggle. So just to summarise that test, all of the soldering irons worked adequately well in my opinion. You know, it doesn't matter whether it's the super cheap one or the quite expensive one, they were all up to the job, although I would say there's some differences, but those differences are probably more related to the tip than the actual soldering iron itself. So with that in mind, I actually ranked the red soldering iron the highest simply because it feels nice in the hand, it's user-friendly, the tip it comes with is pretty decent, and yeah, it's not as expensive as one of them, and it's only slightly more expensive than the cheapest one. So that's why I'm recommending this one if you're just interested in sort of hobbyist level soldering through hole components. Let's move on now to look at these surface mount boards and give that a try. I think this is where we'll really see a difference between the soldering irons. You know, it's not so straightforward to solder a board up like this. So now this is the real test. Once you start making your own circuits, you're on a slippery slope, right? First you'll be using that copper strip board. Next you'll want to make your own printed circuit boards. This is a circuit board I made. It's something for work. It's actually a little half-bridge driver, but it's all surface mount. So these are two big capacitors. There's a MOSFET driver. There's a voltage regulator. These are two D2 pack MOSFETs, and those C1 and C2 are the other sides of the half-bridge. So the circuit's not important. It's all about soldering irons today. So first, I'm going to try and solder a couple of these capacitors here, CLV1 and CLV2. They're 1206 components, which is, in terms of millimeters, it's basically 3 millimeters by 1.6, or 3.2 should I say, by 1.6. So I've got my blue soldering iron warmed up. This isn't a soldering tutorial, but the way to solder these kind of surface mount components is just to put solder on one pad. Then get your component. You need a pair of tweezers. It's almost impossible to do this without tweezers. Grab your component, hold it in place, heat that pad up again, wait till you see the solder sort of stick to the component, and then let go. And you can see it's soldered now. The one thing it's very tempting to do is do all the pads like this and then go and do all the other sides, but don't do that because you inevitably forget to solder this side of some components and then you wonder why the circuit doesn't work. That looks absolutely fine to me. Let's try a bit more of a sterner test. So what I'm going to do next is put the voltage regulator in. You can see the component, it's pretty tiny.
Not exactly sure what component package this is. Is it a D pack and not a D2 pack or something else? So to have any chance of getting this to actually work with this cheapo soldering iron with a pretty big tip, need to make sure the tip's nice and clean. Let's wet one of the pads. You see that the tip of the soldering iron's a similar size to the pad, which is never that helpful. Let's now try and solder this in place. So you get it in the right position on one pad, and then you can do the others. But it's so difficult here, I can barely see. And the soldering iron tip is just so big, it's hard to get between the two pins. You see, see what happened there? It unsoldered the first pin, and now the whole thing's moved and it's stuck in a random position. And that's simply because this tip is too big. So that's kind of a fail. I'm going with a fail for that one. This blue soldering iron, the cheapest one, is not really suitable for surface mount components. But when I say that, I mean you could change the tip. So now I have this red soldering iron heated up. Let's clean the tip. Again, it looks a bit of a chunky tip for this kind of job. Let's put that capacitor in. Okay, so that was no problem. Let's have a look at this component now. So it's not in a great position, but it's difficult to remove. Again, this tip is a little bit big for these fine. You see I've bridged them now. Really you need the hot air gun to take it off once it's on, and then to redo it. That's not really the fault of this soldering iron though. Look at that, it worked absolutely fine. It's definitely usable for this application. I could live with that. This is acceptable, I would say, for surface mount work. Not the really tiny stuff, like the 1206 components, no problem. Maybe 805s, but I wouldn't go any smaller with it for sure. Obviously you can change the tip to something smaller, and then you'll probably be absolutely fine with it. I'll take a new board for the next one. So let's do the 1206s again. So this is the black soldering iron with the temperature control, and this is going to have an advantage in my opinion because it's got the much smaller tip already installed. To be honest, the tip as well looks a lot higher quality than the other soldering irons. That's not coming off the tip very well. I'm struggling with this one. It's not working so well. It's basically, if you can see that the solder's beading away up the tip and not sticking to the board, which is a problem. Maybe because the board's relatively old, it's got some contamination on it or something. Look at the tip, if you can see where the solder is, its bead is up the tip. I was just saying that the tip looks higher quality and then I can't get it to work. Certainly some flux would probably help. So let's wet it there. Let's get a capacitor on. I really thought I'd have no problem with this soldering iron. It doesn't feel hot enough, it's just because that tip's so fine. I've increased the temperature now to 425 degrees centigrade, which is obviously pretty hot. I mean, it soldered it, but it wasn't easy. I think in terms of usability, this is not a good tip. It looks nice quality, I'll be really honest with you, but it doesn't seem to work very well. It's like there's something wrong with the tip, that it's probably too cold. That seemed to work better now. I've turned the temperature up a bit. Let's get that voltage regulator in place. So that worked, but it wasn't nice again. So I've turned the temperature up absolutely full tilt here, and you can see, look, it's still really struggling to get a nice... Oh, you see, it's absolutely awful, and the temperature's as high as it can possibly go. It needs a different tip, and this is the only one it comes with. So actually, I'm not impressed at all with this. It's been difficult for every single one. The tip's too fine, and even when it's at its full heating power, 450 degrees, which is too hot for this solder, and it's still, look at the mess. So I'm not impressed at all with this one actually. I actually prefer the red one. Just for a final comparison, I'm going to look at my sort of personal soldering iron, the one I use at home. So this one is a TS80P. It's like really, it's got this kind of firmware on that so many of these soldering irons have. It's got changeable tips, it's USB-C powered, it's really nice basically. It wasn't cheap actually, but it's really usable, and you can battery power it because it's USB-C, so you just need power delivery battery pack, and you can actually power this from the battery when you're out. So I'm going to set it to 400. So it actually overshot and then came back down, pretty cool. Let's wet these pads, so I'm going to stick a capacitor here. Look at that, look at the difference, night and day. So this is actually a pad for a place for a resistor, but anyway. So easy, so easy. I won't do the other pad because I'll probably need to remove it. This is obviously a much better soldering iron. It costs more money, but sometimes you get what you pay for, and this one just seems so much nicer. Look, it can do all these pads that you know, moderately fancy looking one couldn't really do.
So just summarizing from that little test, you could see that none of the soldering irons were really that great. Even the expensive ones, the sort of $20–$30 soldering iron, didn't really perform as well as I would have liked for soldering those really small components. Yes, you could make it work, but no, it wasn't really ideal. My personal soldering iron, the one I use all the time, this TS80P, actually works really well. You could see a difference. It just felt nicer. It just felt different. It felt much smoother, much easier to solder with. It's got a really nice small tip, but it still gets really hot. So if you're going to be soldering lots of surface mount components, then I'd recommend, spending a little bit extra than these bargain soldering irons to get something a little more user-friendly and professionally built. And just to wrap up this video, I said I'd show you my bargain basement setup for actually soldering really small components. So here I've got kind of a shot from behind me. I'm doing it at work, so you can see it's a bit of a janky setup. I've just got this really cheap HD camera mounted on a post, and it has this microscope attachment which basically screws onto the camera. They're both C mounts, so the microscope adapter fits on really well. And you can see, even though it's kind of a wide angle shot, just look at the quality of the picture on the screen. It's absolutely crystal clear. Of course, there's two things you need to make this a reality though. One is you need a bright light. So if you just use a standard like room lamp, then they're not very good. But I bought this really little light. It's like a USB-C rechargeable thing, and it's super good for that. Also, you need a really solid mount. I'm soldering here at work on a £5,000 optical table. It's not the sort of thing anybody's going to have. So it's really steady, you can barely shake it. It's for lasers and optical work. If you're doing this at home on a desk, you really need to spend some time and effort to get a really sturdy frame built. So for example, like I'm filming this now at home, and if I tap my desk, you can see the whole camera shakes. If that was looking at the PCB now with that microscope, it would be dancing all over the place. You would not be able to use it. So getting a really sturdy mount is absolutely crucial. Something like a monitor stand, which is quite a thick post that you actually bolt to the table, works really well. So that's the setup. I'll link the parts down below, so if you're interested, you can build your own. And yeah, thanks for watching. I hope you found the video useful, and I'll see you in the next one.